Hello everyone. Today I wanted to discuss the Earth's rotation and centrifugal force. As we know, flat earthers like to think that if Earth is a spinning ball and the surface speed at the equator is 1037 miles per hour, then we should all fly off. So a couple of months ago I found a video by this guy. This is Antonio, and Antonio thinks it's irrefutable. The centrifugal force makes the heliocentric model impossible. Now, along with others, I gave my opinion on his explanation, and apparently all the positive reactions he's got motivated him to make a new video. So this time he thought about it, and he thinks there's a relativity problem, as the centrifugal force and gravity aren't working in the same directions. Normally you would say that for every force there's an equal and opposite force. And according to Antonio, gravity and centrifugal force aren't opposite, and therefore the speed of the Earth should make us all fly off. As we don't fly off, gravity shouldn't exist. Well, Antonio is right about one thing. Centrifugal force and gravity don't necessarily work in the same direction. That would only happen directly on the equator. So basically, if you're not on the equator, you are being pulled towards the center of the Earth, but the centrifugal force is on a horizontal line, like you see in the picture here, trying to fly you off. So you'll be in the direction of the spin. Now, as Antonio is correct with his principle, he forgot to do the math. So I did the math and I used myself as an example. I'm quite a big guy. I'm about 6'5" and I weigh about 220 pounds or 100 kilograms. So if you do the math, and I used this tool from calctool.org, on the equator the radius is 3,959 miles. The linear speed is 1037 miles per hour, and my ass weighs 100 kilograms, resulting in a centrifugal acceleration of 0.00 g's and a centrifugal force of 3.37. So that's not that high. I don't live at the equator. I live at 53 degrees latitude. So that's about here. That's 52.96 degrees latitude. At 52 degrees latitude, or 53, the radius is about 2,382 miles, the linear speed is about 624 miles per hour, and my mass still is 100 kilograms, resulting in a centrifugal force of 2.02 and a centrifugal acceleration of 0.0 g's. Now, the radius is smaller because it's a linear thing from the axis. As you can see, this line is shorter than the one at the equator. So that's correct. The speed then is also lower, so that's also correct. But the speed doesn't really interest me. I'm more interested in the RPMs, the angular speed, and as we make one rotation per day, and I'm not going to use the sidereal day, that would be 1440 minutes per day. So 1 divided by 1440 would equal 0.000694 RPMs, which would result in, yet again, 0.00 G's and 3.36 newtons on centrifugal acceleration and centrifugal force for the equator, and for my location that would be 0.0 G's and 2.02 newtons in centrifugal force. Now, of course, the question is this force high enough to let me fly off the planet? So what you want to know is that mass of 100 kilograms is how many newtons of force are trying to pull me towards the Earth. So I googled my weight in newtons and I came to this site. This is thecalculatorsite.com, and you can convert your mass in kilograms to newtons. So my value is 100 kilograms and gravity is about 9.806. So there's a force of about 980.665 newtons pulling on my body, keeping me on the planet. Now, for my location, the centrifugal force trying to let me fly off the planet is 2.02, which is about 490 times lower. And on the equator, it's 3.36, meaning it's about 290 times lower, meaning the force trying to pull me towards the center of the Earth is a lot higher than the one trying to let me fly off the planet. So if Antonio would have done the math, Antonio would have known that what he's saying here is in principle correct, but basically it's a load of bullshit because the values of the centrifugal force and the gravitational force are in a complete and utter different magnitude. So basically it's bullshit. And flat earthers yet again prove they have no idea about scientific principles. Thanks for watching.